In this video, we're going to look at part 2 of special right triangles notes and looking at the special right triangle 30, 60, 90 right triangle. This right triangle, unlike the isosceles right triangle, has two different leg lengths along with a different hypotenuse length. The 4 steps we mentioned in the previous set of notes on the 45, 45, 90 right triangle is going to be the exact same. We're going to label all sides of the triangle. We're going to set the given side equal to the label. Solve for x. Again, sometimes this is already done for you. And then plug in x for the other side lengths. To start, here's your diagram. Again, one leg is longer than the other. So kind of draw a long leg and a short leg. Your right angle's here. This will be our 30-degree angle. This is our 60-degree angle. And this is our hypotenuse, short leg, and long leg. So we're going to call these hypotenuse, short leg, and long leg. Now your short leg is going to be what's referenced to as x. Your hypotenuse is always going to be twice as long, or 2 times x, for the hypotenuse as the short leg. So whatever the short leg is, you double it to find the hypotenuse. So for example, if my short leg was 10, my hypotenuse would be 20. The long leg is going to be the short leg times the square root of 3. Now what makes this more difficult is that the 45, 45, 90 right triangle had only 2 different types of side lengths to memorize, or to utilize, sorry, not memorize. This one has 3 different side lengths. You got to make sure that you hit all 3 in the exact right spots. So if you need to pause this to copy it down, you can. Otherwise, we're going to move on to some examples down below. So the first one, step 1 is always to label. My short side is right here, x. My hypotenuse is here, 2x. And my long leg is x root 3. Step 2 is always to set the given equal to the label. So my given is 5, my label is 2x. So that's my equation. 2x equals 5. That's step 2. Step 3 is to solve for x. In this case, we have to solve for x because x is not by itself. Divide both sides by 2. And we're going to leave it as 5 over 2, a fraction, not a decimal. So I found x. Step 4, you plug it back in. So plug x in to wherever you see an x. So up here, we already know what 5 is. This says x, so I know to put 5 over 2 here. And my side length here. This says x root 3, so that's going to be 5 over 2 times root 3. So just write it as one fraction, 5 root 3 over 2. And that's your final answer. So just like the other special right triangles, some problems are short, some of them are long. Just depends on what the number is and where it's placed within the triangle. Number 2, we have a short leg, 4, so we'll put x there. My hypotenuse goes there, 2x, and my long leg is right here. That's step 1, done. Step 2, set the given equal to the label. So my given side was 4, my label was x, so x equals 4. Step 3, to solve, we're going to skip it because x is already solved for. Step 4, you plug x back in, so we're going to plug, we're going to plug 4 in up here. So 2 times x becomes 2 times 4, or 8. And x root 3 becomes 4 root 3, which can't be simplified. So we're done. All right, go on to page 15. We'll do some more advanced examples. Like number 5 in the center here. So labeling, we have x, 2x, and x root 3, my apologies. That's step 1. Step 2, set the given equal to the label. So x equals 9 root 2 over 2. Step 3 we're going to skip because x is already solved for. And step 4 we're going to plug it back in. Plug this number in. So this says x root 3. I'm going to do my work down here because it's going to take a little bit of time. Instead of x root 3, it's going to be whatever x is next to root 3, which is 9 root 2 over 2. Sorry, it should be root 3, not root x. My apologies. So these two being multiplied together, this is really a fraction over 1. So the result of this is going to be over 2, because 2 times 1 is 2. This 9 root 2 root 3 will be 9 root 6. And going through my checklist, first, there's no rationalization to be done because there's no radicals in the denominator. This cannot be simplified. No perfect squares go into 6. And finally, 9 over 2 can't be simplified because in your calculator, that's as simple as it gets. So there's no other common factor besides 1 of 9 and 2. So that part is done for the long leg here. Up here where it says 2x, we're going to do 2 times 9 root 2 over 2. And remember, 2 is over 1. The 2's essentially will cancel. So you're going to be left with 9 root 2 as your hypotenuse. So you have these two sides they added there. Do one more example. Do number 6. So 6 is going to be 2x, x, x root 3. For my first step. Second step, set the given equal to the label. So 2x is going to be equal to 10 root 3 over 3. Step 3 is to solve. In this case, I'm going to divide both sides by 2. Now, in case you guys forgot, when you divide a fraction by 2, essentially all you do is you take that 2 and you put it on the bottom part of the fraction. So 10 root 3 over 2 times 3. 2 times 3 is 6. So 10 root 3 over 6. Going through your checklist now, make sure that the radical can't be simplified. Root 3 cannot be. And then make sure the numbers on the outside can't be simplified. In this case, they can. 10 over 6 can be simplified to 5 and 3. So 5 root 3 over 3. So I finally got my x value. So step 3 took a little bit longer on this one, but it is done. Now we're going to plug it back into here, which is just 5 root 3 over 3, because it's just a regular x. So that's a really easy plug-in problem. This one, x root 3, I'm going to write it down here. Something root 3, so 5 root 3 over 3, whatever x was, I put it right here. That's over 1, so 3 times 1 is a 3 on the bottom. On top, 5 root 3 is 5 times, these two become a regular 3. And as you can see, if I have 5 times 3, 15 over 3, at this point, you could simplify that to a 5. So my long leg's a 5, my short leg is 5 root 3 over 3. So it's the exact same steps as 45, 45, 90, except you have 3 different side lengths now to label. But the process is the exact same. You're going to still label, set the given equal to the label, solve if necessary, and at the very end, plug x back in wherever you see it. When you're dealing with radicals and fractions, you got to make sure you go through your checklist, make sure the denominator is rationalized, make sure that the radical is simplified, and finally, make sure the numbers outside the radical are simplified as well.